Hello,
Hello.
Jerry.
Hello. Yes. Hi. Hi. Hi, sir.
Yeah, I'm audible to you.
Yes, you're audible to me. Yeah.
Yeah, so I'll just share my screen.
Sure.
Um, so is my screen visible?
Yes. It's about lab 2. It's about the modulation and then demodulation of
Yes, yes,
frequency.
yes,
Yes. The frequency
yes.
modulation
And
signal. Yes.
yeah, and are you able to see my PowerPoint PPT here
Yes. I'm
slide?
able to. Yeah. Yep. Yep.
Oh,
It's good. All good.
okay, okay. So I just before we start, I just like to tell you how are we going to go about, okay, so that you
Okay.
have a roadmap. Once you understand that, then we start with the lecture. Fine?
Yeah. Sure.
Is that okay?
Yeah. It's okay.
Okay, fine.
Can you just
So basically,
just can you just wait for 20 seconds? I'll go and grab something. Sorry about that. Yeah. I'll be back. 20 seconds.
fine.
I'm sorry. I'm back. Yeah. Let's go.
Yeah. Yeah. So I hope I'm very audible to you. No issues with
Yes,
my audio.
you're audible. Very clear. Yes.
Okay, fine. So before we start with the lecture, I'll just give you a roadmap, okay, and a little introduction about myself also. My name is Darren. Okay, I will
Okay.
be
Okay.
teaching you today about modulation. Okay, and we will be learning about the different concepts in modulation and everything. So if I talk about today's lecture roadmap, okay, you able to see my screen? I'm writing on the screen.
Yes, I'm able to see that. Yes, great.
Okay, fine. So, before I went through your lab experiment PDF, before we go through that, okay, I will be giving you a lecture on modulation, okay, wherein we'll be
Yes.
covering what
Yes.
is modulation, okay, or
Yep. Yep.
then secondly, what is the advantage of the modulation, advantages, then we'll be learning thirdly the types of modulation, okay, wherein we have amplitude modulation and we have got angle modulation. The angle modulation gets divided into frequency and phase. Fine. So I will be explaining you this complete thing because this base is required for you to solve this problem. If you don't know these things, then solving this problem will be difficult for you. So I'll give you a roadmap. I'll give you a lecture on this first. And as it is told to me that frequency modulation is something that is very important to you. Correct? If I'm not wrong?
Yes. All this
Yeah.
modulation
So
very
then,
important. Yes, you're right.
yeah. So then frequency modulation, I will be teaching in depth. Please understand this modulation properly when I'm teaching you because I'll be explaining you a number of formulae. Okay. I'll be explaining you a number of formulae. These formulas are going to be very important for you to solve the questions given in the PDF. Fine. So we'll be going through this entire thing, all the theoretical part, all the formulae part. Once this is clear, then we will jump into the PDF and solve the questions given in the PDF. Is that okay? Any issues?
No issue. Good. I
Okay,
just want
fine.
to.
So,
I just want to know that for this course, um, the class test as well as final exam are all open book. Hence,
okay.
he's gonna ask some very difficult questions. So you really need to, understand the concept and then all those things.
Yes, yes, yes. So, yeah, so I will just, make you understand the concept and also the formulae because you need to understand which formulae to be used where. That is very important.
Yes, yes,
So,
yes,
because,
yes, yes. Because
yeah, because
sometimes
as you said that,
you do.
it's an open book. As you said that, it's an open book test for you, correct? So you will have the
Yes,
formula with you. But how to apply it is something that we will
yes,
learn.
yes. Sometimes you're always lost in translation. You get what I mean? It's like you don't know which one to apply. It's just like
Correct.
it's like you do communication system. Then particularly when I'm gonna
Yeah,
listen
yeah.
to your
Don't
to
worry
a
about
tutoring,
that. I will try my
and
best
then
that, I explain you
I'll,
the concepts and to help
yeah,
you understand which formula to be used where. Okay, I'll try my
Okay.
best to explain
Good.
you. So if you
Sure.
see, these are the pre-lab questions, correct? So we will solve all
Yes.
these questions. All these questions will be
Yeah.
solving, and I'll show you how are we going to apply those formulas onto these particular questions. Is that okay?
Yes.
Okay.
Yes, it's
Now
okay.
regarding the experiments, right? These experiments are going to be
Yes.
performed in the lab. So this part is
Yep.
something that I cannot show you here, but I'll explain you the procedure. Okay. And
Oh, okay.
any
That's
one
good.
of the problem over here, I will solve and show you. So that when you perform the experiment in the lab, it will be easier for you to understand. Is that okay?
Sir, can I ask you understand how to do the lab, right? You understand I can send you some lab equipment. I can send you share the picture of lab equipment. Oscilloscope and then how to play around with it. Maybe you can
Yeah.
teach me a little
But
bit.
I believe those things can be learned better when you're doing it in the lab. Okay, I'll explain you the procedure.
Yes. Okay.
But better will learning will be that. And like as I told you, right? See, these pre-lab questions, they are not dependent upon your lab. So this we can solve completely after I give you the lecture about modulation and the formula. But in the experiment part, I'll tell you the procedure and few of the problems I will solve for you, so that you get an understanding and later you can
Sure.
execute that in the lab. Okay. Like for
Yep.
example, in the
Yep. Yep. Good.
demodulation part, I'll explain you the PLL entire procedure. How does it work? Okay. So that when you do it in the lab, right?
Yeah.
So you can do it easily. Again, in the performance of frequency modulation under noise level, I'll give you understanding about what is the performance difference between wide band, narrow band, how do they differ, so that it's easier for you to understand when you're doing it in the lab. Okay. I hope that much is clear to you.
Yep. Understood. Understood.
Okay. So can we
Yep.
begin with the lecture? Any doubts?
No doubts. We start. Yeah. Start now.
Okay, fine. So I will also request you that when I'm writing over here, you can also make your own notes so that you can understand better.
Yes.
Okay. Anyways, this
Absolutely.
lecture will be
Absolutely.
recorded.
Absolutely.
Okay, fine.
Yes.
Okay. Do I need to slow down or am I okay with my speed? Any issues?
No issue with that. If I don't
Okay.
understand, I will interrupt you and then I will let you know.
Please, yeah, please do. Okay. So firstly, we'll try to understand. So
Sure.
we'll try to cover maximum theoretical portion today in the 2-hour lecture, along with a little of numerical. The
Okay.
remaining part we can do tomorrow. Is that okay with you?
Yes. That's
Okay,
okay with
fine.
me. Yeah.
Yeah. So let's try to understand what do you mean by modulation. Okay. So I'll give you the definition firstly, then we'll try to understand. Okay. So modulation, it is a technique. Modulation is a technique in which one of the characteristics, one of the characteristics of carrier signal varies with respect to instantaneous
Instantaneous. Okay.
changes
Uh-huh.
in
Changes.
message.
Uh, in message. Yeah, okay.
Okay, so now I'll make you understand what does it mean. Okay, every word has a significance over here. So it says that it's a technique, right? It's a procedure in which the characteristics of carrier signal. For example, if you know, right, we have a message signal, which is always denoted as M of T.
Yep.
We have a carrier signal, which is denoted as C of T. Okay, now not necessarily everyone will denote the same way, but these are the standard notations. Okay, so we will have a sinusoidal signal, M of T. We'll have this carrier signal over here. Fine. So both of them, if you see, are sinusoidal signal.
Yep.
Fine. So what does it say? That is a technique in which the characteristic of the carrier signal, that too one of the characteristic. That means what? One of the characteristic of this carrier signal varies with respect to the instantaneous changes in message signal. That means what? Now, Jerry, tell me what can be the different characteristics of a carrier signal? It can be amplitude.
Well, I think the carrier signal, the frequency is much bigger than the message signal because they need to transmit
Correct,
the
correct,
thing. So
correct,
you need,
correct, correct. So what happens is that this carrier signal can have multiple characteristics, like amplitude,
yes,
like frequency, like phase. Okay. So the definition says one of the characteristics of carrier signal. So any one of them will vary with the changes in the message signal. So as soon as there is a
ah,
change in the message signal, any one of the characteristic will vary. And that is called as modulation. So
yeah.
am I clear? Any doubts with modulation? This is the most basic concept.
Yeah, this is most I understood about this, but sometimes, you get to the latter stage, you talk to FM and then you talk about all those FM changing message or changing all those kind of things, you start to get confused, energy and then
Don't worry, don't
power
worry,
and
don't
then
worry. Don't worry.
double
I'm over
double
here
angle
to make that
formula,
confusion easy for you.
cosine, and then all those things that start to collapse. It's like,
No, no, no. Don't
start
worry.
to
I'm over
confuse.
here to make your life easy. So don't worry about it. Okay.
Yeah, yes, yes.
So yeah. So I hope that at least this modulation part is clear to you. Any doubts with this?
Yeah. No,
Okay.
this part's clear.
Okay. So
So
okay. So let's try to one more time revise. Modulation is a technique in which one of the characteristics of the carrier signal varies with instantaneous change in the message signal. I hope now in the exam if this question comes, you'll be able to write the definition properly. Correct?
sure. Understood.
Okay. And this is the part. So wherein you have a message signal, you have the carrier signal, and any one of the characteristics, amplitude, frequency, phase will vary as the message signal varies. But it is any one. You cannot have amplitude, frequency varying both together. Any one of them will vary. And that leads to the type of modulation. So if amplitude varies, we have amplitude modulation. If frequency varies, we have frequency modulation. If phase varies, it is phase modulation. But it is always
Yes,
one of
absolutely.
the characteristics of this carrier signal varying with the message signal. I hope so much is clear. Any doubt?
No, no, it's okay.
Okay,
Yeah,
fine.
understood.
Okay, now the next thing, if you know, modulation can also be roughly defined as the process in which the low frequency signal gets converted to high frequency signal. So we
Okay.
have as even you said me that the carrier signal frequency is very high, right? So ultimately, the modulated signal, right? The modulated signal will have high frequency signal, correct? So what
Uh-huh.
happens is that modulation is the process will go lower frequency to higher frequency. So Jerry, do you know this formula? C is equal to lambda by lambda into F.
Yes, yes.
Yeah. So what will lambda be equal to? C by F, right?
Yeah.
Now imagine if the modulation is telling that it's going from lower frequency to higher frequency, that means if the frequency increases, the lambda will reduce.
Yep.
Now, the length of the antenna, right? The antenna which is used for the propagation purpose always will have approximately as lambda by 4, generally.
Mm-hmm.
So what happens is that modulation makes my life easier. Modulation converts lower frequency to higher frequency, because of which my wavelength reduces and my lambda by 4 reduces. Hence, it doesn't cost me more to, you know, make an antenna. The length reduces.
Yes, absolutely.
So, yeah, so this is one of the most important advantage of modulation. So is this clear? Any doubt till here?
No, it's very clear.
Oh, okay, so these 2 points that we have learned what is modulation, what are the different types of modulation, amplitude, frequency, phase, and why do we apply modulation. I hope this,
Okay.
so much is clear to you.
Yes.
Okay.
Because modulation is related with antenna, isn't it? And then antenna is basically is related with lambda, which is the wavelength. So
Correct,
basically,
correct.
obviously, with different kind of
Yeah.
frequency,
So
you
what
expect
happens
different
is
kind of
that
wavelength.
if what happens if you imagine if p is equal to lambda, sorry, if T is equal to lambda f, and lambda is equal to c by f. If my frequency is very less, my lambda will be very high.
Yes.
Eventually, my length of antenna will be very high, and that will cost me more, and practically impossible also. So modulation
Yep.
makes life easier for me.
Okay.
Okay. Okay. So now the next concept is the first type of modulation, that is the amplitude modulation.
Okay.
So I believe if you know the basic definition of modulation, you can automatically create the definition of amplitude modulation. What can you say? It is a technique in which the the amplitude. If you remember what was the definition of modulation, one of the characteristic, right? Since this is
Yes.
amplitude modulation, we'll have amplitude, in which the
Mhm.
amplitude of the carrier signal varies with respect to instantaneous change in message signal.
Okay. Understood.
Fine.
Message signal.
So
Yes.
if you know the basic
Absolutely.
definition of modulation, you need not by heart the definition of amplitude modulation. You can automatically write the definition.
Yep.
Right? Okay.
Yep.
So now let's try to draw the graphs. The graph that you were telling me that confuses you a lot. Let's try to draw it. Okay. So if you see, okay, before that, let us try to understand few equations. Okay, in amplitude modulation. If you see, as I told you, the amplitude, right?
So sorry. Can we stop for a few seconds? I have some problem with one of my assignment. I need to make sure that I actually submitted the whole things. Wait, let me just check something. Because we had an assignment for control engineering. Can we stop for a while? I just need to check the things. I'm sorry.
So for how much time do I need to stop?
No. I will mute myself. I will be back. Give me a few minutes.
Yeah. Okay.
I'm back. Yes, sir. I'm back. Okay, so this is the formula for amplitude modulation, I believe.
Okay. So yeah. So basically, I'll tell you the formula later. First, let's try to understand the basic. So please understand this thing very properly. How do we write a message signal or a carrier signal representation? Okay. So this is the way that we write. So AM indicates, for example, I have this signal, right? I have M of T and I have a T. Imagine I have this kind of signal. Okay. So AM indicates the peak value and this is minus AM. Similarly, if I have a carrier signal, I can write as C of T. I'll have a signal which is AC and minus of AC. So understand this and note it down. That M of T is written as this, C of T is written as this, because these are the basics when the question comes. In the question, they just give you a representation of CT and your M of T. You should be able to pick out from that what is the amplitude, what is the frequency. If you know the standard representation, you can take out what is the value of AM and FM from that particular question. Am I clear?
Yep.
Okay. So now, if you see, what did the definition of amplitude modulation say, Jerry? It said the amplitude of the carrier signal varies with the message signal. Correct? So what is the amplitude of the carrier signal? AC. Do you agree?
Yeah.
So the AC can be told directly proportional to M of T.
Yes, absolutely. Wait, AC can be directly proportional to M of T. Why is that? AC can be directly proportional to carrier. It cannot be directly proportional to.
No, see what I'm saying. The amplitude of the carrier signal varies with the instantaneous message signal. So
Okay. So the amplitude of the carrier signal varies with respect to instantaneous. Okay. I get what you mean. So these two are correlated. So basically, this whole sentence. I get what you're saying. Yeah. So the amplitude of the carrier signals is associated with the changes in the message signal, because the message is the most important thing. We need to send the message, and then the carrier is like, run in parallel with that. So it's obviously, they run in parallel, so they do together. So that's why. That's why the carrier signal, a message signal, can be related with the amplitude of the carrier signal is related with the message. Okay, I get what you're saying. Okay.
Yeah. So
Yes.
now if I just try to, put a equal to, I can say it as this, wherein your Ka is defined as the amplitude sensitivity.
Okay.
If my humble request, Jenny, when I'm writing these terms, please make a note of it and understand it. If you have any doubt,
I am. I just ask.
Okay,
I
if you
will.
have any doubt, please ask me. Because what happens is that here, if you don't understand, okay, and if you do the questions, you will be totally confused. What is AC? What is AM? What is FM? What is FC? You will not understand. So please understand these things very well. If you understand this thing, then solving the question is not going to be that difficult. Okay. Okay. So now I show you how does the amplitude modulated wave look like. For example, I have your M of T. I have your C of T. Finally, I have your signal. This is a modulated signal. Okay.
Okay.
So what happens is that if you see, I'll just draw and show you. Okay? Just try to understand. Let me first draw it, then I'll explain. Are you able to see this? See what happens. When the amplitude of my message signal, M of T, increases, the amplitude of my carrier signal also increases. And when the amplitude of message reduces, the amplitude of the carrier signal also reduces. Any doubts in this?
Beg your pardon again? Yeah. So this is the modulate, this is the overlap, superposition.
Yeah, so what happens if you see? See, when my amplitude is going high, right? It's towards the peak, AM. what happens?
Yes.
My carrier signal also amplitude increases. And when the message signal is dropping down, the amplitude of the carrier signal also reduces. Are you able to see this thing?
Yeah. Oh,
So
yes,
we
yes. So
say,
it varies. Okay.
yeah, so we say that AC is directly proportional to M of T.
Yes.
As the M of T increases, the AC increases. As the M of T reduces, the AC reduces.
Oh, okay. Yes, yes.
Fine? Okay. So now
Yeah.
we will. Okay, so now I will be just going through amplitude modulation, not in very much detail, because we need to talk more about frequency modulation. If anytime later you want a session
Yes.
on amplitude modulation, we can do it. Okay, but this is just the
Yeah,
basic part.
we can do that. Yeah. Yeah.
Okay.
Because I want to focus on 40 figure. But so I always thought that you need a lot of solid amplitude modulation background, and then you can proceed into frequency modulation. Otherwise, it's gonna get confused.
Yeah.
Isn't it?
So
Oh, I'm wrong.
yeah. So whatever is required for your frequency
The
modulation, that
lab
much
test.
part only will cover amplitude modulation. Else, if you are interested,
Okay.
we can take that later. Okay.
Yeah. We can do that later on. Yes, but it's okay. We just focus on this part first. Yes, sir.
Okay. So this was about amplitude modulation. Any doubts still here, Jerry?
No, it's fine. Yeah, so you're very clear. Yeah, you're quite clear. Yeah,
Okay.
I'm happy with that. Yeah.
Okay. So now I'm not going much into depth of amplitude modulation. We'll start with the frequency modulation, which is the objective. Okay. That is fine.
Okay.
Okay. So now we have the angle modulation. The one of the subtypes of angle modulation is frequency modulation. Okay. So the angle
Okay.
modulation divides into two types. One is the frequency modulation. Other is the phase modulation.
Uh-huh.
Any doubts in this?
No. So basically, the
No.
changing frequency and changing angles. Yes. So basically, changing say theta isn't it? Phase is theta.
Yeah. So now that's the reason I taught you amplitude modulation so that we can relate the same concept in this modulation also. Okay. Before we go to frequency modulation,
Yes.
I'll give you a brief idea about phase modulation. Then we'll jump into the frequency modulation, which is the objective of today's class. Okay. So what do you mean by phase modulation? So Jerry, can you define phase modulation for me?
Phase modulation is a technique in which the phase of the carrier signals varies with respect to instantaneous changes in message signal.
Excellent. Very good. Right? So what happens is that if I talk about, imagine I have my C of T. Normally we should write C of T as this, right? If you remember.
Oh, yes.
But now there will be plus phi of phase to that. So in phase modulation,
Okay.
so what happens in phase modulation? Are you clear with this point? Is it correct? Any doubt in this?
Yes.
Okay.
No doubt. Very clear, sir. Very clear. Very good.
Okay,
Very
so
good.
this is Kp into
So
now here. Yeah, tell me.
wait. So I got his notes. His bloody notes. His notes is obviously he's talking a lot about frequency modulation and then talk all those things. So is it sometimes? No, it's okay. So let's continue.
Yeah.
I just bring up his notes because actually you
My
have his
my
notes.
my only aim in these lectures will be to simplify you the concept. Okay? Because if
Oh,
you're
okay.
learning
Not to
communication,
overcomplicate.
yeah, because if you're learning communication, it is expected from you that you should know modulation very well. Okay.
Okay.
And my only aim will be that I make it easy for Jerry. Okay. I'll
Okay.
try my best.
Okay.
Else, let's see. Okay. So as you
Yeah.
remember, Jerry, that in case of your AC was directly proportional to M of T, right? So AC is equal to K into M of T. So we had Ka, right? Similarly, here we have Kp, where Kp is the phase sensitivity.
Oh, okay.
Yeah,
KP, the cases. Wait, let me jot this down. So, but this is
yeah.
important now. Phase modulation. Okay, and CT. So, how long have you been teaching this course? I suspect you're a very experienced guy with this kind of subject.
Like because I am very much interested in this kind of courses, so I try and my aim is that students should be able to understand the concept properly because only
Okay.
reading it is difficult to get the concept.
Yes, it is very abstract, very abstract, and very easily to get distracted.
Yeah. So see, Jerry,
Okay.
did you understand when I taught you modulation and when I taught you just amplitude modulation? Once you learn that, it is very easier for you to learn the other modulation. Just the terms will differ, but the process and the method will remain the same.
Yep.
Correct. So see how I just wrote for you phase modulation, and without writing the definition, you told me about the definition because you understood the previous concept properly. So
Yep.
just understand one modulation properly, then it will be easier for you to understand the other modulations also. Am I clear?
Yes. Yes.
Okay. So now what happens is that my so this is the basic form of your phase modulation. Fine. Now we are heading into the most important type, that is the frequency modulation.
Yes.
That is what you are requiring. Only why I took those lectures is that for you to understand what is modulation. Because frequency modulation is a little complex. If you don't understand the basic properly, it would have been very difficult for you to understand frequency modulation. Okay?
Yes.
So now, since you know the other modulation technique, it will be easier for you to understand. Fine?
Yep.
Okay. So first of all, Jerry, please define frequency modulation for me.
So the frequency modulation is basically is the technique in which the frequency of the carrier signals varies with the instantaneous change in message signal.
Wonderful. I hope I feel that now you started understanding the lecture properly.
Yes, because you're good. You're actually not bad. You're a lot better than some of the lectures I had, for communication system. Although
Is
we
this
didn't get
clear?
into the complicated calculation, but yeah. But generally speaking, very clear. Very sharp. Yeah,
Yeah.
the basics.
So
We
P of
start
t is equal
basic.
to AC cos 2 pi FCT. Okay.
Yeah, yeah,
Now what
yeah.
happens? A similar procedure. There's nothing different. So don't get scared of frequency modulation. FC is directly proportional to M of t. Is it right?
Yes, yes, yes.
So FC is equal to KF into M of t.
Yep, yep, you're right.
And what do you feel KF will be, Jerry?
The sensitivity, the frequency sensitivity.
Correct. Yeah. So it is just that the method remains the same, just the terms keep on differing. Am I clear to you?
Yes.
Okay, so please, Jerry, when I'm writing this now, make a note of all these points because
Yes, I'm
now
making
from
notes
now
of
on,
it.
yeah, so because from
Yes,
now on, all these terms will be used in the problems.
yep,
Okay,
yeah.
okay. What do you feel, Jerry, will be the unit for KF?
Or is it ohm, I suspect, or it's
No, no. See, KF is equal to FC upon MT.
yep,
What is FC? Frequency hertz
yes.
per volt, amplitude.
Oh, okay.
Anything difficult?
Not really. Wait,
Yeah,
frequency of the carrier over the MT message. Okay, so it's a hertz
because the
and
frequency
then volt.
unit is given by hertz and the message is
Yes.
always given by volts,
Yeah.
right?
Okay.
Amplitude. So just it is about understanding the basics, Jay. Once you understand the basics, then for you building up will be easier. Of course, you need to study
Yeah.
hard and you need to practice, but basics have to be clear. Clear?
Yes. Absolutely.
Okay.
Absolutely.
Okay.
Absolutely.
So now I'm writing two standard mathematical expressions. I write here two standard mathematical expressions for FM signal. Please make a note of it. We'll be using it in the numericals further.
Okay.
And in communication, you will have to remember little things. So my only request to you will be that please keep on revising your notes from time to time. Depending upon your
Yep,
memory
absolutely.
ability, please keep on
So
revising. It will be easier for you.
that's active learning, isn't it? Active learning. So it's like
Yeah, always keep
you
on revising it. It will not be difficult for you at the time of your exam.
okay.
Clear?
Yep.
Yeah. So why you should remember this definition is no. Sometimes in the paper they'll give you just a random mathematical saying that s of t is equal to 2 cos 2 pi 10 raised to 3t plus 2 sine 2 pi 10t. They'll give something like that.
Yep.
So if you know the standard expression, what happens is that it becomes easier for you to remove the elements from this. So then you'll know my AC is equal to 2 volts. My FC is equal to 10 raised to 3 hertz. My beta is equal to 2. FM is equal
Yep.
to 10
Okay.
hertz. That is the reason you need to remember this two standard definition. Clear? Any doubts?
So the second equation, the second part, is beta sine 2 pi FMT, is it?
Yes.
Oh, okay, because I just want to make sure because that one looked like F, but I'm not sure whether it's F or it's not F. Okay.
Yeah, it is F. It is F.
Okay. Okay.
Okay. And okay. So did you understand? So these two definitely are very important. Wherein beta is called as the frequency modulation index. Any doubts?
No, it's good. Frequency
Okay, these
modulation
two
index,
things are
yes.
important. Now, slowly, we will go because I want you to understand properly so that when we solve the numerical which are given in your PDF, right, you should not get
Yes.
more worried. And at least the basic numerical, you should be able to solve it. Okay, the
Okay.
complex one definitely will take some time. Fine. Okay.
Absolutely. Absolutely.
Okay. So I just go again. Frequency modulation is a technique in which one of the character in which the frequency of the carrier signal varies with the instantaneous change of message signal.
Yep.
FC is directly proportional to M of t. FC is equal to KF into M of t, where KF is the frequency sensitivity. What will be the unit of KF? There is no need to buy it. Just do
Yeah,
KF
yeah.
is equal to FC upon M of t, that is hertz per volt.
Yep.
Next, two standard definition of FM of t. AC cos 2 pi FCT plus 2 pi KF integral minus infinity M of t dt and S of t is equal to AC cos 2 pi FCT plus beta sin 2 pi FM. I
Yep.
hope I'm clear with this. Okay. So now there will be lots of more formulas coming up. So make a note of it. Don't worry. We'll try to understand how these formulas are derived. Okay. Any doubts here, Jerry?
No, I'm good. I'm good. I'm good,
Okay.
sir. I'm good. Trying, sir.
Next,
Try to
you have
understand.
frequency deviation.
Uh-huh.
Given
Frequency
as
deviation.
delta of F is equal to KF into AM. What is KF, Jerry?
AM is the amplitude modulation, is or it's
No, what is KF I'm talking?
oh KF. KF is the frequency sensitivity.
And what is AM? AM is the peak amplitude of message signal.
Oh, okay.
right? If you remember, I drew this M of t, right? This was t, this was M of t. So when I draw this signal, right, this is AM, this is minus of AM.
Okay, understood.
This is the
Understood. I'm on
peak.
board.
Okay.
Okay.
I hope you're not getting bored with the lecture.
No, I'm not, sir. You make me very energetic, sir. Very good. So it didn't make me fall asleep, you know.
Okay. So now what is
Good,
F
good.
max? Now see, we should know that del of F is equal to F max minus F min, basically, if you remember this.
Yep.
Of course, the frequency deviation will be max minus min, right? So the F max is given as Fc plus Kf into Am, and F min is equal to Fc minus Kf into Am. So
Yes.
eventually, you get Fc plus Kf into Am minus of Fc plus Kf into Am.
How two? Okay.
Am I clear?
Uh-huh. FC plus this one. Okay. Wait. Let me digest a little bit. So basically they have delta F is FX minus FM. Then it will be two FC is wait. It will be KFAM plus two KFAM, is it?
Yeah, correct. I just wanted you to identify this thing only. 2 times
Okay.
Kf into Am.
AM.
So right? Are you clear till here? 2 times Kf into Am?
Yes. Absolutely. I'm clear. Yeah.
Yeah. Yeah. So what happens is that my del is F max minus F min is given as this thing. That is very important. But why do we always consider the formula, of your del F as Kf into Am? Because we are talking just with respect to the upper part, the peak part. We are not talking peak to peak.
Well,
We
we're
are
not talking
just
to
talking
P2P. We
about
just told. Okay.
fine. So this is something very important. So I just revise you. Don't worry. What was frequency modulation, Jerry? Can you repeat again?
So the frequency modulation is a technique in which the frequency of the carrier signals vary with respect to instantaneous changes in message signal.
Okay, so FC was directly proportional to?
FC is directly proportional to MT.
So FC is equal to KF into MT. What is KF?
Yes. KF is the sensitivity, the sensitivity, isn't it? The frequency
No, there is
sensitivity.
frequency sensitivity. Then there is no difference, right?
Yeah.
K is also
Yes.
sensitivity, but K is
Yeah,
amplitude
but
sensitivity. KF is
yeah.
frequency. Please be specific with the terms. Okay. Then please repeat these two mathematical expressions which is used to denote FM signal.
Yes.
Can you repeat both the signals?
Repeat.
Please read it one.
What? Yeah, so it's ST is equals to AC cosine 2 pi FCT plus 2 KF and an integral of the message signal.
Yeah. And another
And
definition?
then otherwise the ST is equals to AC cosine 2 pi FCT plus the beta. Beta is the frequency modulation index. And then is equals to sine and then is 2 pi FMT,
Correct. What is the value of frequency deviation? Del F given as KF into AM.
Wait, what again?
The del F is given as KF into AM.
Oh, yes. KF
Okay,
into
so
AM,
please
yes.
remember this
Two,
standard
no,
definition.
not one, two KF AM.
No,
Right.
correct. But generally we represent as this because we are just indicating the formula, the peak value, not the peak to peak value.
Oh, okay.
Okay. So till here, I have made you understand also, and I hope in the class only you have remembered all the formulas because I don't
Yes.
want you to go back home and bang your head against your books. You can just practice and revise in it.
Yeah.
Okay. Okay. The next formula says, you remember beta. What is beta?
Beta is the frequency modulation index.
Yes. That is given as del F by Fm. The next formula.
Delta F over what?
Huh?
FM. Beta is delta F over FM, is it? Oh,
Yeah,
okay.
delta F upon Fm. Yeah. Clear?
Yes. Yeah, absolutely.
Okay. I hope that you are understanding and you're not getting bored with the lecture.
No, no, sir. I'm good. I'm good.
Okay, fine. I understand the things are little boring and little difficult to understand. But if you make an effort, definitely you'll understand. And I'm trying my
Yes,
best
yes, absolutely.
to keep you alive in the
Yes,
lecture and
absolutely.
not
No,
make
I
you
know, I
bored.
know, I know, I know. I know, sir. I know, sir. You try your best. Yes, I know. I understood. Yes, that's why sometimes I interrupt because I don't understand. Yeah. So if I
Yeah.
don't understand, I start to interrupt. Yeah. Let's go.
Okay, now we come to the next part of the story. We have got the beta value, right? This beta value divides frequency modulation. Means the frequency modulation gets divided further into two types of modulation, depending upon the value of beta. What are those modulation? Do you know this thing, Jerry?
A little bit lost, sir. Can you tell me about it? More elaborate more on this.
Okay. This is the narrow band pass FM.
Oh yeah, band pass.
The
Right. So
wide,
they have the different band pass, right? They have the low band pass and the high band pass, all those things. Yes.
so here
Narrow
the
band.
beta value is smaller than 1. Here the beta value is greater than or equal to 1.
Yeah.
Clear? Any doubts here, Jerry?
Wait. Let me digest a little bit. Modulation. Okay, and then they have the uh-huh.
Hello? Hello?
Wide band pass. So beta is more than 1, so it's wide band now.
Please remember it's greater than and equal to also.
Yes. Oh, equal. Okay. Equal. Understood.
Because sometimes what happens is that, imagine I'm giving you a question straight away. They might give you a signal like this, right? So firstly, you need to know this standard mathematical expression to find out the value of beta, right? Then you understand the beta is equal to 2. So since beta is equal to 2, you realize that this is the wide band pass effect,
Yes.
right? So this is a straightforward question. They might give you mathematical expression and they might tell you, identify the kind of FM signal. Okay? Hello?
Yes. I'm here.
Hello?
Yes.
Yeah. Yeah. Till here, any doubts? You want me to change my teaching method, something issue?
No, sir. You're good. So I just yeah. Let's go, sir. Let's go.
Yeah. So okay. So now let's try to dive into the first type of modulation, FM modulation. That is the
Okay.
NBF,
Narrow band
the
frequency modulation.
narrow band frequency. What is the value of beta, Jerry?
Less than 1.
Is this right?
No, it's less than 1, isn't it? Not equal, less than 1.
Correct. Absolutely. I'm happy that you're attentive in the class. Good.
Uh-huh.
Okay. Now this comes with a mathematical expression. Let's try to write it. More than this, just try to write down this expression. Kindly don't write this the expression there, okay? Because this is the generic expression,
Okay.
right? I'll tell you the expression which is used
Yes.
for NBF. Okay, write down this expression. I'm sorry for that. Let me know once you complete writing.
Wait. So you have to minus the imaginary, is it? This is I, is it? Or it's cosine minus cosine? Oh, okay. Cosine.
It is basically this minus cos 2 pi fc minus fn.
Oh, okay. Understood. Okay. So the plus will be minus, yes, because the band is how the signal works. You have the positive and the negative. So you need to the right and then the left. All those things. Yes. Okay.
Okay, so
I get what you're saying.
basically this is the standard definition. In communication, you have no other option than to remember mathematical expressions, remember formulas. Just
Yeah,
the
but
thing is,
so it's an open book, So we need to understand it.
no, I
The
understand.
important
I
thing is
think it is an open book, but then you have the exam in a certain time period, right? So when you have a certain time
yes.
period, it's very important for you to understand properly. Okay, because sometimes open book tests are way more difficult than closed book tests also.
Yes.
Okay. So now we'll try to draw the spectrum. Have you heard this word in your classes? Is it taught in your college?
Yes, I have. Yeah, spectrum is like various frequency, right? It's like a
Yeah.
band of things.
So basically,
It's
this
like
will
a
always,
light spectrum.
yeah, so this will always indicate with the impulsive. Okay. And now
Yes.
I'll teach you that there's no need for you to remember how to draw spectra.
Oh.
If you know
Okay.
the if you know the equation, Jerry, I will teach you how to draw the graph spectrum.
Yes.
Okay. So this is given
Yep.
as frequency and this is given as the amplitude. You can say S of t, which is my modulated signal. Okay.
Wait. So say that again. I'm sorry. I wasn't paying attention just now. I'm sorry.
Okay. So
Can you
what
say
I'm
that
telling
again?
is that now this is the frequency, the x-axis,
Okay.
and the
Okay.
y-axis is the S of t. Okay. So now if you
Okay.
see, there is a FC, right? There is a FC.
Yeah.
So I'll just mark a FC over here.
Yep.
What is this, Jerry?
Plus FM.
Yeah. So I'll write it here. Correct?
Uh-huh.
It's plus. What is this, Jerry?
Minus FM.
Correct? Anything difficult here?
Not really. Very
Okay.
clear. Very clear.
Now, what is this value given as AC, right?
AC. Yeah.
Just indicate this with AC. What is value for FC plus MN and FC minus FM? Beta AC by 2.
BAC divided.
But
Yes.
FC plus FM it is plus. So I will draw Did you understand this, Jerry? Or you got confused?
No, I understood. But so I saw you have to work in pairs, isn't it? This shit getting increasingly more difficult. I believe yesterday my lecture says in pairs or something. Am I saying it correctly or I'm wrong? Pairs. And I have to count how many pairs is it, like 2 plus something plus 1, because is
That
it
is
something like
the
that?
number of sideband that Jerry will talk in terms of wideband first FM. Okay, that's a
Okay.
different. We will talk about it. So, but remember, Jerry, always when we draw a spectrum, no, whatever is the mathematical expression, we are going to all divide all expression by 2. So this will
Yes.
become this.
Ah, okay. Why is because it's peak to peak, is it? Because in this case, we don't want peak to peak. We just want peak values divided by two.
Right, right.
Okay.
So am I clear? Was it difficult to draw the graph, Jerry?
Not really, sir. And then I think later on you have some bezel or something, bezel or those kind of things. You have to
Yeah,
read the
don't worry. First,
table.
we'll try to understand this, then we'll try to understand. Okay.
Yes, yes.
Now,
Okay.
what happens? I'll try to show you the pair partition. Now, what happens is
Yeah.
that, see, in real world, Jerry, there's nothing called as negative frequency. Okay. But when
Yes.
we learn theoretically, no, we draw it as a mirror. So my negative part will be a mirror of this. I'll draw it. You tell me if you have any doubt, or you tell me that, sir, what you have drawn is wrong.
Okay.
So you're in engineering currently?
Pardon?
Are you in engineering currently?
Yes, I'm studying engineering, sir. Yes.
Yeah.
What do you think I ask you for tuition? You know, this is important stuff. Yeah. A lot of people do very bad in this course. It's a very polarized course.
Yeah.
It is what it is.
So did you understand this?
Yes, I do understand this. Your lecture is good. Delivery is not bad. Very good.
So we are just drawing a mirror of it.
Yeah, this is a mirror. Yes.
So this is the pair actually. Here we'll always have a pair to it.
Okay. Understood.
Okay, so Jerry, tell me, if you just know the standard equation, will you be able to draw the spectrum by yourself?
Yes. So, what do you mean? What do you mean? Can you say that again? What do you mean? You
What I'm
mean can I
saying that
draw this spectrum by
if you
myself?
know this, if you remember the standard equation, okay, is
Ah,
there any
ah.
need for you to remember that spectrum also? No, you can draw it by
No,
yourself.
no. You just
Correct?
yes. I just need to play around with it.
Yeah.
Yes.
So yeah. See. So also see what I am teaching is also been taught by your college professors also. Is also
Yes.
present in your books also. My
Yes.
aim is that to make things easy for you. Because
Yeah.
I understand that when I was a student, it was very difficult to remember so many things. So I'm trying to cut down the things that you don't need to remember. So you remember the basic
Yes.
things,
Yes.
which are itself a lot in communication, and other things you can just do it logically.
Yes. Absolutely.
Okay. Any doubt clear, Jerry?
No, sir. Clear, sir. Let's go. Sir, let's go. Let's go.
Okay. So from here we'll find the bandwidth. The bandwidth is given as, do you agree with this?
Yes.
Okay. And the power transmitted, Jerry, is given as this formula basically. I'll explain this formula in detail for you.
Wait. So can we take a break? Short break. 3 minutes break. So it's very
Yeah,
tiring for
yeah,
me.
sure.
Very tiring for you.
Sure,
I
sure.
want to recharge.
Okay, so can we meet in 2 minutes?
Sure. 2 minutes.
Okay.
Have a break. So I'm back. Let's go.
Hello, am I audible?
Yeah, you're audible.
Okay. So did you note the definition of bandwidth and
Wait,
your
so hang on. So I have to reply a message. So
hello?
yeah, so I have to reply a message. Sorry, my friend just sent me a message. She want to ask me how to use oven. I'll be back. Yeah, 1 minute. So.
Hello?
Yeah, so wait, please wait. My friend have something urgently want to ask me. Sorry, sir. I'll be back, sir. I just want you to know, yeah. I'm not walking away or anything. Yeah.
Hello?
Yes, sir. Wait. Yeah, sir. I'm back. Let's go, sir. Hello, sir. I'm back.
Yeah. Am I audible to you?
Yes.
Uh, did you write this formula? This one? Bandwidth and this one?
Wait, no, not yet. You know, yes. Wait. Yes, bro. Finish already. Yes. Let's go.
Okay. So
Let's
I'll
go.
just explain you what is this PT basically. PT is basically the transmitted power of the modulated signal of FM. Okay. So if you see, can I break this as this, Jerry? Am I right in doing this way?
Yes. You're correct. Yes.
So
Wait.
this
What's this
stands
PC? What
for,
is PC?
yeah,
Can
I'll
we
tell you
can you
the
just describe?
carrier power. The carrier power.
Okay. Carrier
And this
power.
is the sideband power. So basically, the power of this signal is the PC, and the power of this plus this is PC beta square by 2. So you can
Okay.
reduce.
Okay.
So you can reduce it as this for
Wait.
each sideband.
What the heck is this? Why is this? Why? Oh, divided by two, so each sideband. Oh, okay. Understood.
Because there are
Sideband power.
two,
So
one
each. So
for one, it is PC beta square by 4.
yep.
Right?
Each
Okay.
sideband. Yes, each sideband. Well. Oh, okay. Yeah.
Any doubts here, Jerry?
No. Okay. Understood.
So I hope you're understanding. I'm not boring you. You're not getting bored with me.
No. I'm not.
So I will just revise this frequency modulation again before we go to the wide band pass session. Okay?
Yes.
I'll just revise it. Okay. Okay, so what is frequency modulation? Frequency modulation technique in which the characteristics of the carrier signal varies with instantaneous change of your message signal. Okay, your C of t is given as AC cos 2 pi FCT. Fine. Where your
Okay.
carrier
Okay.
signal will be directly proportional to M of t. Kf is equal to Fc by M of t. Kf is equal to Hertz per volt. And the Kf is given as frequency sensitivity. There are two standard mathematical expressions for FM, irrespective of NBFM or WBFM, which is given as AC cos 2 pi FCT plus 2 pi Kf integral minus infinity to t M of t dt and AC cos 2 pi FCT plus beta sine 2 pi FMT. Am I clear?
Yes.
Okay. What is the frequency deviation? Frequency given as del F, which is Kf into AM. Fine. The beta, which is the modulation index for frequency modulation, given as del F by FM. Fine. Now, the any
yes.
doubts?
Correct. Correct.
Now, the frequency modulation can be further be divided into two types: the NBFM and the WBFM. NBFM is beta smaller than 1. WFM is beta greater than 1.
Yes.
So you have narrow bandpass FM and the wide bandpass FM. Clear?
Yes. Absolutely.
Okay. So for narrow bandpass, let's write one narrow bandpass FM properly before we go to wide bandpass FM. Else what will happen is that it totally get mixed. So first, clearly understand what
Yes.
is narrow bandpass FM. Narrow bandpass FM is basically having modulation index beta as smaller than 1. S of t is given as AC cos 2 pi FCT plus beta AC by 2 cos 2 pi FC plus FM into t minus cos 2 pi FC minus FM into t. So I have this spectrum
Yeah.
diagram. I have FC, FC plus FM, FC minus FM. Draw this diagram properly. Always, whatever is the amplitude, divide by 2. And this is plus, this is minus, because we have minus over here. And then bandwidth is given as 2 times FM, and PT is equal to PC into 1 plus beta square by 2, in which PC is the carrier power and this is the sideband power. And if they ask you individually about sideband power, it is PC beta square by 4. That is divided by 2 over. So they might give you a particular question and they might ask you all these quantities. Tell me PT, tell me bandwidth, tell me this, tell me that. If you remember the concept and you remember the formula, you will be able to do it. So my humble request is that, Jerry, I will teach and I will go away. Okay, but you have to write the exam. So please make the notes properly and keep on revising it, because then only you'll be able to answer the paper well. Else, just by teaching you won't make any sense. Clear?
Yes.
I want you to do well in the exam.
I know. That's why I'm coming to you, sir. Yeah. I understood. Let's go, sir. So this is a narrow band. We can have the wide band. Hello.
Yeah.
So
next you have the wide band pass FM. Okay, so what is the value of wide band pass FM beta value? Jerry?
Greater than 1, greater or equal. Okay.
Right? Okay. Now, in case of wide band pass FM, we have something called as the Bessel function for switch. That is something you need to not know in depth, but know the basic, and how do we denote it? Okay, we'll use this a lot in wide band pass FM. J and beta. Clear? Any doubts till here?
So Jn is a constant. It's not a constant.
This is basically a Bessel's function. You'll have different values, like J0 of 1, J0 of 2. That will be given to you in the paper. That's not an issue. Okay. Any doubts still here?
Yep.
Can we move ahead?
Not really. Okay, sorry.
Okay. I hope it's not becoming overdose for you.
No, no, no. It's not overwhelmed. No, it's okay. So
So the Bessel's function will have certain properties. So that you need to understand. I understand FM is a little complicated, but I'm trying my best to make it easy for you.
yes,
Okay. So J and beta. So this is J and beta. Okay. This value
yes.
will keep on reducing as n keeps on increasing. So is it right for me to write this way? Is it right based on this?
Uh, yes. I think so. I think so. I think so. I believe so.
So what you can say is that as n keeps on increasing, right? It was 0, 1,
Yes.
2. The
Yep.
value of J
Yep.
and beta keeps
Yep.
on
Yep.
reducing. Okay.
Yep.
So I'm trying to give you every property with the explanation so that you can remember it well and not just by heart it. Okay.
Correct. So it is should be correct. This is should be correct.
Next is this property which you need to remember actually. This is the. And the third thing is that, okay, and again you have mathematical expression for wideband processing, which is given as remember this. You have to remember mathematical expressions, formulas in your for yourself. Although it's an open book test, but then you should know that this is a mathematical expression for something. If you don't know only, you'll get confused. Okay.
Oh, okay.
So even
Okay. Okay.
it's an open book test, it doesn't mean that you don't remember that. You have to remember that as much as you can.
Yes. Yes. Okay.
Okay, so now I will draw the spectrum for a wide bandpass system. Fine.
Yes. Yes.
So let's try to draw the spectrum for a wide band. Again, what I told you last time, Jerry, if you know the expression, you need not remember how to draw the spectrum. You can draw it on your own, correct? So the same way
Yes.
it comes here. So let's try to find out here. If you see, no, Jerry, if you see, it's given as what is given as, just give me a minute. Just give me a minute. I'm sorry. Just give me.
Yeah. Yeah. Sure. Hello, sir. Are you back? Oh,
Hello?
you're
Hello?
yeah, sir. Are you back?
Yeah. Yeah, 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 yeah. Am I audible to you?
Yes, you're audible. Let's go.
Yeah. So did you write this like equation?
Yes, I did. I did. It's plus and minus, right? Yes.
Yeah. So now we'll try to like write it over here. Okay. Like what are the kind of equations and everything? We'll try to write. Again,
Nice.
it's the same thing. We have F, we have, if you just talk about this to be FC, I'll write here to be FC plus FM, FC minus FM, FC plus 2 times FM, FC minus 2 times FM. Anything wrong in this?
Not really. Okay.
Okay. Now if you see,
Uh-huh.
this N and this N is the same, right? So when N is equal to 0, I have only FC, correct? So then it will be AC J naught beta. So try to understand. If you don't understand, tell me. I'll make you understand again. But try to understand.
Yeah. Okay.
See, when N is equal to 0.
Wait, divided by divided by 2 is because of peak to peak, is it? So it's half.
Yeah, the half part let it be. That we'll try to understand later. But first you try to understand this. When N is equal to 0, this is only cos 2 pi FCT because NFM is 0. And here we'll have
Yes.
AC J naught beta. So the AC J naught beta comes here. And as I told you, always in terms of spectrum, we divide by 2.
Yes.
Okay. Similarly, what will be coming over here? AC J1 beta by 2. AC J2 beta by 2. Here AC J minus 1 beta by 2. AC J minus 2 beta by 2.
Minus
Am I
FM,
clear?
FC minus 2 FM. Okay. Sure.
Okay.
Yeah,
Now,
yeah, sir. You're very clear.
yes. Now, please understand one thing. I don't know how you have drawn it. Remember that if this is here, this should be here. And the impulse signal length should keep on reducing. Why should it keep on reducing?
Yes.
Because of this property
Because
which
the
I told you.
intensity, isn't it? Yep. Absolutely.
Okay, as n keeps on increasing, the J1 beta reduces. Eventually, the total value reduces.
Yep.
Any doubts till here?
Absolutely. Yes. Yes, I'm still here, sir.
Okay, now we have the bandwidth formula and the power formula. As we learned for NBFM, we learn for WBFM also. Okay. So for bandwidth is over here. There are two ways to define bandwidth. Have you heard about Carson's rule? Hello.
Carson's rule, yes, something like that. Yes. So I have heard about that.
Okay.
Yes.
Okay, and you have the other rules, which is the other one. There's no particular rule to name to that. But in case of Carson's rule, the formula says, and here it is. You remember you're talking about the pairing and everything?
Wait. So this is what? Can I ask the notation before that beta one? What is that? Delta or what?
This is 2 into beta plus 1
Okay.
into
Okay. 2. Yeah. I got confused. Okay. 2. Okay. This is 2 FM, right?
Yeah.
Okay.
Okay, there are two ways to define it. And the pairing that you were talking about was this thing only. There's always a pair, right?
Yes.
Okay. And n indicate a positive sideband. That means what? Now in this case, the number of positive sideband, how many, Jerry? Can you tell me? Number of positive sidebands?
There are about 5. 4 plus 1, so it's 5, right? Number is 2 times 2. Yeah, 2. I know. So I want to give I want to give you the total thing, so you get what I'm saying? It's 5.
Yeah,
so,
but
yeah,
sir, n indicates over here the number of positive sidebands. So this is the
2.
carrier, and this is the number of 2 positive sidebands. Clear?
Yeah,
So many times, if you see the PDF that you have given me, there are questions that tell the number of sidebands. So that will remove by this formula. I'll show you how we do. Okay. Now, power.
Yes.
What is the value of power? Okay. There are two values of power in case of wide band pass system. PT is equal to PC and PT
Okay.
is equal to PSB, which is PSB when beta is not equal to 2.41, 5.5, and here when beta is only equal to 2.41, 5.5. That means what? If the values become equal to 2.41, 5.5, beta value, you will have to use this formula. And for any other value except this, you will have to use this formula.
Wait, so what is that? B equals to 2.4155, is it?
These are the values of beta, basically. So basically, they might give you a question, right? So you might get beta in that
Yes.
2.41, 5.5. If it is so, use this formula. If it is not 2.5.5, use this formula. Where your PC
Okay.
is given as AC square by 2R.
Yes, yes.
Where AC is the amplitude of carrier signal and R is the resistance.
Yes.
So any doubts till here?
Yeah.
Any
Yep.
doubts?
Yep.
Okay. So can I revise this entire concept once? Because this is the end of the theoretical part. So
Oh,
can I
really?
revise once?
This is the end of the theoretical part. So you are
Yes.
sharp, huh? You basically covered these entire things, huh? We might able to do some amplitude modulation. So can you just do a little bit of amplitude modulation? I want some revise on amplitude modulation. Or you
But
think
then
this is
that
too much?
but then that was not included in the scope of this particular lecture, right? So we'll try to
Yeah.
have frequency modulation and the problems on that. If you want to learn about
Okay.
amplitude modulation from me, please tell Aditya sir. He will let me know. Then I'll prepare and teach you afterwards. Okay.
Oh, okay, okay, okay. Then yeah, then let's just focus on the frequency. Yeah, sure. So this is the part.
Okay.
This is the whole thing. So this multiple pages I wrote. This is the whole things.
So I
Okay,
hope you
understood.
understood something.
Understood.
You didn't get bored of me.
No, it's all right. But so I feel like the devil is the detail. The complex. All those how do I call it? The proving all those things, times Fourier transform. Those are the really challenging part. Yeah. I mean, now we just talk about very the bigger picture. The detail is difficult, sir. But
Yeah.
you're okay, sir. You're good.
Yeah. So basically, let's try to once revise before we dive into the
Yes.
numericals. Today
Okay.
we'll mostly cover this theoretical part. Tomorrow, what
Yep.
we will do is that see what I'll be teaching you. I'll tell you, beforehand only. Now we'll revise
Yeah.
the entire syllabus, entire theory one that we learned right now. Okay. Tomorrow,
Yep.
once we learn all the concept, we will be solving this pre-lab questions. So
Okay.
whatever formula we have learned, the questions will be from your own. So just apply those
Okay.
questions. I'll make you solve those things. So all these questions we
Okay.
can solve from what we learned today. Since it's only for frequency
Okay.
modulation, I'll be only teaching frequency modulation. If you want other topics lecture from me,
Oh.
it's my humble request. Please talk to Aditya sir and tell him the topic properly. I will teach you that. Give me some time after. Okay.
Yep. Yep. Sure. Understood. Yeah,
And
this is
then
priority.
with
This
respect to
this
the
is
experiment,
quite big.
yeah,
This is very big. This is
yeah,
this assignment is very big. This assignment is like 10%. It's like quite
yeah.
big. So it's like we do well for this lab, because I did quite bad for the test. The test is worth about 5%. But next test is gonna be quite big. So our next test is 10%. So then it start
Okay.
to building up
Okay, so
momentum,
basically
building up
what happens is
sizes.
that
So it's
with
like
respect to the experiment one, right? With respect to the experiment one,
experiment two.
we have,
Yeah.
yeah, okay. So here it is something that you will be doing it in the lab, okay? And only when you do
Yep.
in the
Yep.
lab that you understand the thing. What I can do is that is that I can teach you the concepts of communication properly. I can make you solve the problems which are over here, right? Properly.
Yeah,
And
yeah,
I
yeah,
can give you
yeah,
a brief idea about the concept. Like, you're seeing here the demodulation technique, this and that I can teach you. Okay. But the lab
yep, yep,
practical is something that you'll have to do in the lab. That I can't help. But
yep.
the formulas and the concepts and everything I can teach you properly. Okay. So now we will revise whatever we have learned today properly. Tomorrow's class, we will be solving these pre-lab questions first. And later on, this is a part of experiment, but I will teach you the theoretical aspect of it. Okay. Not of the lab, but like for example, what is this PLL? I'll explain you what is PLL. What is
Yeah,
the
yeah, yeah,
performance of frequency under what? I'll just teach you all this in brief. Okay. The lab
yeah,
part
yeah.
I
So let's
cannot
go.
help.
So let's
Okay.
go.
Yeah. So are we ready to revise this thing once?
Yes, yes, yes. We're ready.
Okay. Okay. So what is modulation, Jerry?
The modulation is basically, I mean, it is basically is a technique in which one of the characteristic of a carrier signal varies with respect to instantaneous change in message signal.
Yeah. So what is the advantage of modulation?
Well, you can, basically you can allows the carrier message signal to, to transmit much faster alongside with the carrier signal. That's why you need to modulate. You
Okay,
need to
fine.
tune it better.
Yeah, and what happens is that the frequency reduces because of which my
Yes.
lambda so the frequency
You
increases.
have to,
Because of
yeah, if the frequency increases, then the wavelengths decrease because it's the basic C equals to F lambda.
correct. And then the length of antenna will automatically reduce. Okay, which will help us cost wise
Yes,
and
yes.
everything. What do you mean by
Yeah.
amplitude modulation?
It's a technique in which the amplitude of the carrier signal varies with respect to the instantaneous changes in message signal.
Okay. And what is the expression for amplitude so AC is equal to K into M of T. So what is KA?
Yeah. Amplitude sensitivity.
Okay, fine. Okay, so as I told you, there is a lot more to amplitude modulation. But since I was told to do frequency modulation, I've concentrated on that. If you require lectures in the future
Yes.
on amplitude modulation, you can let Aditya sir know. Okay, he'll
Yeah,
let
yeah.
me
So
know.
I'll let you know. I'll let you know. I'll let you know. It's
Okay.
great.
Okay, so what do you mean by angle modulation? And what are the different types of angle modulation?
So there's a frequency modulation and there's a phase modulation. So basically, the frequency modulation is, is a
No, first let's
technique
talk
in
about
which
the
the
phase modulation. Phase modulation
okay,
is
so it's a technique in which the phase of the carrier signal varies with respect to the instantaneous change in the message signal.
correct. So what is phi c is equal to
Also,
Kp into
FC is
MT?
equals to KP So KP is basically the phase sensitivity.
Okay, can you tell me the Kp unit as I told you for
The KP,
here?
the KP unit is a hertz per volt.
Kp, not Kf.
Oh, KP, KP radius, phase of radius per volt.
Radians.
Radians,
Like you
yes.
have degrees, right? Since this is the phase angle, it is radians. Okay. Okay. Now coming to the main part, frequency modulation. What is frequency modulation?
Frequency modulation, is it's a technique in which the frequency of the carrier signal varies with respect to instantaneous changes in message signal.
Okay. Fc is directly proportional to m of t. Therefore, Fc is equal to Kf into m of t. What is Kf?
Yep. KF is the frequency, is the frequency sensitivity.
Okay. Now frequency sensitivity. What is the unit of Kf?
It's hertz per volt.
Okay. What are the two standard mathematical equations for FM signal?
So it's basically st equals to a cosine 2 pi fct plus 2 pi kf, and then the t and then negative infinity mt dt. And then, the second part is st ac cosine 2 pi fct plus b sine 2 pi fmt. So it's basically something like that.
Okay, so what is del f? What is the maximum frequency deviation formula?
Delta f is the maximum and then the minimum, right? So it's basically so delta f is like peak amplitude and then kind of kf frequency deviation.
Yeah. So it is
Deviation.
kf into m. So it is kf into am. Fine.
Yeah.
Next.
Yes. Absolutely.
What is beta is equal to?
Beta is called the frequency modulation index.
Yeah, it's del f by Sm. Okay. Now,
Yes.
based on beta, on what two kinds of frequency modulation gets divided?
The narrow band and wide band. So narrow band is beta less than 1, and then wide band is beta more than 1, more than equal to 1. So basically, it's probably with beta, is to do with the modulation, frequency modulation index.
Great. Okay, so what is narrow band pass FM? Beta is smaller than 1, right? Now, so tell me the mathematical
Yes.
expression for it.
So it's basically AC cosine 2 pi FC T plus beta AC divided by 2 cosine 2 pi FC plus FM times T, and then minus the 2 pi FC minus FM times T. So it's basically something like that.
Okay. So Jerry, now are you capable to draw the spectrum diagram from the given mathematical expression?
Yes, I am, sir. I am.
Okay. Please, of course, after lecture, keep practicing also. Okay. I teach you,
Okay.
you will feel everything nice, but if you don't practice, you will forget. Okay.
Yes. Use it or lose it
What
mentalities.
is the bandwidth of a narrow bandpass system?
What's the what?
What is the bandwidth?
The bandwidth is the bandwidth is 2 FM FC plus FM minus FC minus FM, so you get 2 FM FC cancel.
And what is the total transmitted power of NBFM?
Total transmitted is PC plus PCB squared divided by 4. So it's basically each sideband, I assume. It's not the sideband.
It is PC plus PC beta square by 2, not 4. If I further divide it, it will be this way. See, it is this way ideally.
Each sideband, yes. Yeah.
PC plus PC beta square by 4 plus PC beta square by 4. Any doubts in this? This is equal to
Not
this.
really.
This is the carrier. This is the total sideband power. Okay.
Yep.
What is WBFM?
WBM for wideband now. Wideband frequency modulation. Wideband. Wide frequency. Yeah. WBFM.
Because beta is greater than or equal to 1. Okay.
Yes.
Next.
Yes. And then
next. What do you mean by Bessel's function? In which the J and beta value keeps on reducing as my n value keeps on increasing. Okay?
Yes.
These are the properties. Tell me and repeat the mathematical expression for wideband pass FM signal.
Pardon?
The mathematical expression for wideband pass FM signal.
Yeah, it's ACJN beta cosine 2 pi FC plus FM, and then minus FM, and then plus 2 pi FC minus FMT. The same, yes, plus and minus.
Plus plus NFM into T. NFM.
N what?
FC plus or minus NFM into T.
Oh, N plus N. Why is N? N is okay. So N. Oh.
N is the number of positive sideband.
For narrow for wideband there's N, but why for narrow there's no N?
Because here we are indicating in terms of the Bessel function, right? N. Hence the N specifically. Okay. Do you know the? Did you understand?
Okay. So why for narrow band there's no basis function?
Because the Bessel function is applicable when the beta value is greater than or equal to 1. Beta value smaller than
So if it's So it will not show up. It'll be gone. There's no values or whatever, is it?
Beta value, the base function is defined for beta greater than or equal to 1. I clear to you?
Okay. Understood. Understood. Very clear, sir.
Okay, so what is the bandwidth for wide bandpass FM? What are the two formulas?
Uh, what is, what is the two formula? It's 2b plus 1, 2b, no, 2 times b plus 1, and then FM,
B,
and
no,
then
beta,
another one is
beta.
2 in FM.
2 times beta plus 1,
Beta is the
not beta.
index, isn't it?
Yeah, 2 times
Yes,
beta plus
yes.
1 into
The
2 into n
beta is
into n.
the index,
Okay. What is the
modulation
transmitted
index.
power?
So in the power, so it's AC square over 2R. It's always like that, you know. And then for amplitude modulation, it's like energy is 1 over 8 or something. AC square, yeah. But we'll see about that.
So
Let's
again,
go.
I'll write this over here. When your beta value is specifically 2.41 or 5.5 anything, your PT is equal to PSB. But for any other value except this, my PT is equal to PC is equal to AC square by 1. I hope I'm
Okay.
clear with this. Okay. So there
Yes.
are two things, Jerry, which I want to tell you as a teacher. See, all what I can teach you is firstly communication concepts or any subject concept. Okay, depending upon your requirement, if I know the subject, firstly, and secondly, the problems associated to that. So as I
Okay.
told you that these are the problems which are over here, I can solve these problems for you, which are
Yeah,
over
also
here.
the tutorial
Okay.
question. I assume tutorial question as well.
But this experiment section is something that you yourself have to do in the lab. Okay. Here I can only
Yes.
explain
Yes.
you some of the processes like PLL, this and that, and I can help you with some of the things. But except that, this is a lab part. Experiments is a lab part. So that part you have to do yourself in the lab. But the theoretical concept and the numericals is something I can cover if I know the concept. Okay. So
Yeah.
I think
Good.
we are done
Understood.
for today's 2 hours lecture almost. So tomorrow we'll deal with this problem solving part. Please
Okay.
remember all the formulas well, note it down, because all those formulas are going to be used over here with respect to frequency modulation.
Okay. Yep.
Any doubts, Jerry? You didn't find my teaching okay? You have any complaints? Anything? You can tell me honestly.
No, 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 not really, sir. Very clear. Very clear. Very clear. Quite good. Huh? I'm happy, sir. I'm honestly very happy. We'll do the lab tomorrow. I will arrange a time with you tomorrow, and I'll text to the guy, later today about what time we free tomorrow, and then we, do a session. Yeah,
Yeah, I
probably
will
do a morning session.
uh, I'll request that if this time will be that also will be better for me also, because I'm also available tomorrow at this time only. So if this time is good for you, we can do at this time only tomorrow. It will be
Can we
good
do
for me.
a little bit early tomorrow? Like a little bit early,
Fine, not an issue, not an issue, not an issue. You can just tell him if I'm available, I'll let
okay,
you. Okay,
okay. Thank
accordingly.
you, thank
So
you, thank you,
tomorrow,
thank
I
you. Yeah.
repeat, we'll be solving the numericals, not the lab portion, but the pre-lab numericals. For the lab portion,
Yes,
I cannot explain you, but I'll explain you the process so that at least it helps
yes,
you in
yes,
the tomorrow in the lab.
yes, yes,
Okay.
yes, yes, yes. Okay, thank you very much, sir.
Okay. And
Bye, sir.
okay. And one more thing. And also with respect to the amplitude modulation, all those concepts, if you're interested, you can tell him. We can have different classes for that. Okay.
Yes,
Thank
yes, absolutely, absolutely, absolutely. Thank you. Okay,
you.
so you might have to share with me this recording, and then I think we're done, sir.
I think Aditya will be sharing. I think Aditya sir will be sharing. Aditya sir? Um, Aditya sir, आप हो? Uh, let me call him and see if he's available.
Yeah, do you want to text to him or something?
Yeah, no. I'll just call him and see once whether he's available. 1 second. Give me a minute. But I hope, Jerry, today's class was clear to you. I was neither too fast, neither too slow, and you enjoyed it and you didn't get bored.
No, no, it's okay.
Okay, and I hope that you are a little more clear with communication. At the start of the class, you were telling me that you're not understanding anything, but now I think hope you're better.
Yep, yep.
I'm happy. So what's the time now over there in Australia?
It's a 7 6:56.
In the evening?
Yeah.
Oh, okay, one time wise. One second, let me just trying to call Aditya. 1 second. Yeah. And one more thing, Jerry. Any other point that you want me to improve? You want me to change or something which is
No,
not
so
suiting
it's
you?
very it's very clear, sir. You have been very clear. I think we just stick with this now, and I will send you some tutorial questions, and we can go through those as well. And try to make me a
And
better
one more thing, Jerry. One more thing,
better.
Jerry. If you want me to solve some more trivial question, something like that, please give those questions to me in advance. Okay, so that even I
Yes,
get
yes,
some time
absolutely,
to prepare.
absolutely. Yeah. Prepare. Yeah, I know, I know, I know. I'm aware of it.
Because
Okay,
I
thank you.
because I never like to just solve the numericals. I like you to show how those formulas have come to the numericals. Else you will get confused what to apply where.
Oh, okay. So you want to apply first, and then you just jump into that. Yeah.
Yeah,
Okay.
even in today's class I could have directly solved the numericals, but I didn't
Okay.
do that. I told you what is the concept. Now solving those numerical will be a little easy for you tomorrow. Okay. So tomorrow we'll try to
Oh,
complete this PDF, means the numerical part. If necessary, something we can do on Sunday, else tomorrow we'll try to complete. Okay.
yep.
Okay. Let me try Aditya this answer again. I think just wait for 2 minutes. He should be, I think, joining me. He's busy in a call, I believe.
Okay. Okay. Sure.
हेलो आदित्य सर, आप हो क्या? हेलो आदित्य सर, आर यू देयर? हेलो, हाँ जी, आप जरा इस पे आ जाइए ना, जूम पे. इसको म्यूट करूं?